Welcome to our sixth video on Year 10 probability. In this video, we're just going to recap some of the work we've already done on Venn diagrams. So before we start, let's think back to all these key terms and key symbols. So we said the word element means all of the possible outcomes in a universal set. So for example, if you was looking at rolling a dice, six-sided dice, the elements would be number 1, number 2, number 3, number 4, number 5, and number 6. So all of those possible outcomes, but each individual one is called an element. The universal set is all of the options, so that whole group of elements together. So if you're rolling the dice, that's roll 1, 2, 3, 4, 5, and 6. So all the sides, that's your full universal set. Then you have those subsets that are smaller. So if you're doing rolling the dice, you might be looking at the probability of rolling an even number or an odd number. That would be a subset. The complement is the opposite. And remember, when it comes to our Venn diagrams, that complement is quite important. Okay. Cardinal numbers. Now, that's the total. So if you're looking at, say you're looking at a universal set for rolling the dice, your cardinal number is 6 if it's a six-sided dice. Okay, the probability of rolling a 6 is 1 out of 6. But the cardinal set, the number of options that there are, in that case, is 6. So a little n doesn't mean the same as the PR for probability. The little n means how many there are in that set. A null set means it's empty, there's no values in it. The intersection, that's when you're thinking your Venn diagrams, that's that middle bit where the two circles overlap. And the symbol we use is there. So remember, it looks like an N, intersection, looks like an N. And the union, that's all the elements within both of the circles. And remember, Venn diagrams can be more than two circles, okay? But it's all of the elements within the circles and within the intersection. That's the union. And remember, when we're using that mathematical notation, union is the U in between the A and B. Mutually exclusive. So this is where you have two circles, but they don't overlap because there's nothing that the two subsets have in common. Alrighty, so we're going to have a range of pictures now that Dora's put together for us, and with each of them we're going to talk about what it's showing. So the first one here, everything within the rectangle is coloured in, both subsets A and B, the intersection and all around it as well. That's showing your full universal set. Everything, whatever's in A, whatever's in B, whichever's in both, and whatever is not in A or B or both. So the whole area is highlighted. Where if we move on to this one, this is the union between A and B. So everything is in A is highlighted, everything in B is highlighted, everything in the intersection's highlighted. But anything that's not within the union of A and B, so inside the rectangle but not within that union of A and B, is not highlighted. Okay, now the highlight in here is showing us the area that is the complement to A and B. So you see how it's the A1 and the B1, that means not A or B, okay? So not in A or B, okay? Remembering that means total, the N means the total, so neither A nor B. Okay, here we have the things that are in the intersection of A and B. So what's highlighted is the intersection of A and B. Here we have everything which is not in the intersection. So we have any elements in A that are not shared with B, any elements in B that are not shared with A, and any elements that find themselves not in A and B. The only thing not highlighted is the intersection, and you see our notation there. So we're saying not, because we've got that opposite outside, that complement, not the intercept of A and B. Okay, so here we're looking for A only. So what we're looking at is the total of A and the opposite, so the complement of B. So nothing in the intersect's going to show up there, because that would be A, that would be the intersect of A and B, wouldn't it? So this is just saying what is A on its own. So nothing in the rectangle, nothing that falls in B at all. Okay, here we're showing everything that is not in A. Okay, so we're showing B. We're showing outside of the union of A and B. Okay, but anything that's in A is not highlighted. So it's the opposite of A. Everything highlighted is outside of A. Here we're showing only things that fall in B. Okay, so nothing that falls in A, nothing that falls outside of A. So only B. And here we're showing the opposite of B. So we are showing everything that falls anywhere which is not within B. So everything highlighted is outside of B. And here we're showing some sets that are mutually exclusive. They do not overlap at all, and therefore in the intersection between A and B there is nothing. Big thanks to Dora for putting those images together for us, and I'll see you in our next video.